So in order to answer this question, we need to write suvat down the side of our paper. Remember, any kinematic equation questions, always write down what you know before you start to do anything else. So in this case, we want to know the maximum height of the ball. We're going to take acceleration as minus 10 meters per second squared because we're taking upwards as positive because it's going upwards. It's entirely up to us how we choose that, and we usually just choose as we feel like, really. So, what else do we know? We know the initial velocity is 20 meters per second. We also know the final velocity because at the maximum of anything that's been thrown up, the maximum displacement, it will stop. Just briefly, but it will stop. So at that point, the final velocity is 0. And we don't need to know t yet. So we need to find an equation that has those 4 quantities in. And this time we're going to use v squared is u squared plus 2as. If we substitute in what we know, then we find that the maximum height reached by this is 20 meters. We now are asked to find the time of flight, and there are 2 ways that we could work with that. We can either set the displacement to 0 because the object has gone up and back down, so although it's travelled the distance, it's 0 displacement because displacement is a vector, remember. So we could do that, or we could use the displacement that we've just found of 20 meters, find the time for that, and that will be half of the time of flight because objects that are thrown up, their flight is symmetrical and they take as long to go up as they do to come back down on the whole. What we'll do is set displacement as 0. So using s is ut plus a half at squared. We put our numbers in. We get that 5t is 20. So the time taken for the ball to return to its starting position is 4 seconds. If we'd have done it the other way, we'd have got 2 seconds and then simply doubled it. Now, have a go at these questions. Remember, write suvat down the side of your paper.